Server process.
The question is, which process reads the data from the disk into and brings it into the buffer cache? So, no, DBWR. Not DBWR, server process, a dedicated server process or a shared server process. We haven't seen what a shared server process is. So that is our diagram. I will again draw our usual diagram, the SGA, and this is my buffer cache, and this is my hard disk here, and my system database file, then sysocs, then this is undo, this is temp, then I have control files, so these are data files, at least that many. Then we have control, so let us say I have one file called as c1.ctl, another file c2.ctl, and then we have the redos. So redo is the next thing, and redo files are, at least you need to have two of them. These are called as actually groups. So redo 1 and redo 2. So the question was, which process reads the data from the data files and brings it into the buffer cache? The answer is server process. The dedicated server process is what we have seen so far. Then the next question is, how do you find the size of your SGA? You have prepared this thing, but now you know you have forgotten. How do you find out the size of your SGA?
Show SGA.
So that is a command here. I think we have not seen this thing. Show SGA is the command that will tell us that. Any other way? I think we have seen a view, data dictionary view. Which view is that?
Instance.
No. See, I will tell you a couple of ways. There is also another command called as show parameter. Show parameter and the name of the parameter. So for example, show parameter db underscore block underscore size. It will show you the value of that parameter.
What about $SGA stat?
That is the next thing that I was going to show. So select star from $SGA stat, and that SGA stat will actually show you not just the size of your SGA, but it will show you the sizes of all the smaller component within SGA. So you have to actually write the sum of that, and that will be the total size of your SGA. So any of these things, so I would say either show SGA, that is number one. Second thing is, come on in. Second thing is, grab the share. Second thing is show parameter SGA target size. SGA target, not SGA target, not SGA target size, SGA target. Not the command show parameter SGA max size. There is a fundamental difference between the SGA target and SGA max size. SGA target is the size of your SGA, and SGA max size is the maximum limit that you can have on your SGA size. So the answer to the question, we were discussing a question, how do you find out the size of your SGA? So either you type the command show SGA, it will show you the size of SGA there, along with a lot of other subcomponents also there. Then there is another command show parameter, and then SGA target, SGA underscore target. It will show you the value of that SGA underscore target. And then $sys SGA stat. I like to go because this is the most accurate information here. The total sum of all the bytes in that $SGA stat will also show you the size of your SGA. So that was kind of the second question I had. Then the third question I have is now how to find out the standard block size of your database. When you created the database, what was the standard block size?
8K.
But how do you know that? I may have created the database with the 8K block size, and you may have created with the 2K block size. How do you find that out? Show parameter db underscore block underscore size. So as simple as that. Show parameter db underscore block underscore size. So db. So that is the parameter which will tell us the value of this parameter is going to tell us what is the value of your db block size. Once the db block size is created, it cannot be changed. It cannot be changed. So this brings us to a very interesting discussion. Is like, let us say initially I thought my system is going to be an OLTP system, online transaction processing system. We have seen what is an OLTP and what is an OLAP. OLAP is for decision making, and OLTP is for transactional systems. So initially I thought my system is going to be an OLTP system, and therefore my block size was low. OLTP have lower block sizes, OLAP have higher block sizes. But then little later on, I also realized that I need to do certain analysis in the same database, and therefore the size of the block should be a little higher, because we are going to read huge amount of data. While reading huge amount of data, it is good to have the bigger block size, because IO is done on a block by block basis. Even if you need to read one row, you are going to read the whole block. If you need to write one row, you are going to write the whole block. So just for one row, we are going to read, let us say, 32 kilobytes. So that should be an OLAP kind of a system. So my question is, initially we thought that our system should have a lower block size. Little later on we realized no, it should have been, or for maybe some queries, it should have been a higher block size, the performance can improve. So is there any way to change the DB block size? The answer is no. Once it is decided, it cannot be changed. But there is kind of a workaround. You create a new table space. And that new table space, how do you create a table space? Create table space, the name of the table space, then the data file, the size of the file, and everything. And at the very end of that create table space command, you specify a block size. That means this new table space will be of size maybe 100 megabytes, and in that new table space, the blocks will not be the standard block size. They would be little different than the standard. For all other table spaces that we have created, the block size would be, let us say, 2K. But for all, this create table space command will have a different block size. And then those specific tables, which should be kind of used for the OLAP analysis, should be kept inside that newly created table space with a bigger block size. So how do you kind of work around with the change in the block size requirement? You create a new table space with a different block size. You create a new table space with a different block size. But now that brings us to another important topic. So let us say these are all the table spaces with a block size of 2K. And now you decided you want to have another table space. The name of the table space is TS1, and the block size of this, I'm drawing it below the whole thing. Huh? Okay, are you able to see this?
Last one.
Okay, so let us say there is a table space called as TS1 that we are going to create, and I want this table space to have a 32K block size, the very bigger block size. So as I said, you have to fire the create table space command, and at the end of that you say block size 32K. But before you do this, you need to make sure that any block in this data file is going to be of size 32K. When this block is going to be read from here into the buffer cache, the buffer cache should have equivalent size of buffer. This is called as a block, this is called as a buffer. So the size of the buffer should be big enough to accommodate the size of the database block size, which is now bigger. So you have to actually now another initialization parameter, db nk, right? In this case, is it the nk or I need to check that actually. I keep forgetting the name of the parameter. db okay, now db and now in our case it would be 32K nk cache size. So this is an initialization parameter that you must set in your init.ora parameter. And what should be the value of this init.ora parameter? Let us say I specify this as 100 megabytes. I specify this as 100 megabytes. So what is going to happen? There will be an area, let us say equivalent to 100 megabytes, that will be reserved inside the SGA, and the size of that area is going to be 100 megabytes. And in this area, 32K blocks would be read, and they would come over here as buffers. These would be 32K block size. So before you create a new table space with a different non-default block size, you must specify this initialization parameter option. So obviously if your block size was going to be, let us say 16K, the initialization parameter is called as db 16K cache size, and the value of that is going to be whatever you give. So this is the discussion about DB block size.
If that table space is not accessed, that space will be not used by other.
So if there is a table called as employee in this table space and nobody has written any query on that employee table space, then this space will not be utilized. That is, so this is reserved only for the 16K blocks. So that is the discussion about the block sizes. Then the next thing is how to find out the total number of users connected to your database. I think we have seen this yesterday, but still, what is the answer? $V session. So let me talk about $V session a little bit. In $V session, there is a column called as username, which is a very important column there, and there is a column called as SID and also serial hash, serial number. So these are like three important columns in the table, in the view $V session. In the $V session, you will see one row for one user connected to the database. So if there are 100 users connected to the database, you will see 100 rows, and actually, in fact, you will see more than 100 rows. You will see 115 rows maybe in Oracle 10G. What are those extra 15? For each of the process which is running in the background. Let us say DBWR. DBWR is a process running in the background. LGWR is another process. CKPT. All these different processes which are running in the background. For each of those processes, there will be one row in that $V session. So even if nobody is connected, for those 15 processes, we know only 5 of them which are mandatory. For whatever process which are running, there would be one row over there, and the username for those processes would be null, NULL. So that means nobody is logged in. Those are just the connections for the background processes. For all the other users who are logged in, the username will have the value of the user that is logged in, and then it will have some numbers in the SID and the serial number. Now these two numbers are extremely critical from the DBS point of view. And why are they critical? Because many times you will require to kill a connection. You will be required to kill a connection. Why you would kill a connection? For example, somebody like it happens over here multiple times. Somebody who is working on the data warehousing project, they write a very wonderful PLSQL program, and they schedule that using the cron to run in the middle of the night, and what they have written is an infinite loop there. So that will suddenly start taking huge amount of resources. The server probably slows down. A lot of slowness is experienced. So at that time, a DBA will have to come in, and he will have to identify that user there, and then he will have to find out the SID and the serial number. So let us say the SID is 10, serial number. These are the unique serial hash. These are the unique numbers that are given by Oracle. Just like on Unix, PID, process ID is given, which is unique. These numbers are unique. So once you find out the SID and the serial number for that user, you execute this command. You must be logged in as a DBA. Alter user, alter system. Alter system, right? Alter system, kill session. And in single quotes, you are going to write SID as 10 and serial number is 104. Okay, so once you write this command, what happens? What happens behind the scenes? Once you write this command, then the process, which is the dedicated server process. So let us say this is the dedicated server process, which is actually connected to the data, and this is the client process here, which is the client process. And this dedicated server process will be killed. Now there is one thing that important thing that happens, and that is when the dedicated server process is killed, what about some of the rows it might have deleted? What about some of the locks that it may have acquired on certain objects? So all those rows that were deleted are rolled back. That means they are brought from undo and put it back into the original blocks. And all the locks on the object, anytime you delete a row, update a row, there is a row level lock, there is a table level lock. We will see locking a little later. But all those locks are released, so two things will happen. So data will be rolled back, and the second thing, the locks are released. Locks are released. So this is what happens when the session is killed. And who does this thing? There is the process called as PMON. So now we have seen another purpose of PMON. Yesterday we saw what is the one of the main purposes of PMON, that is to register dynamically with the listener that I am the process which is running, and then I'm the database that is running, and I want to register with you, and that is done by PMON. And today we are seeing one more purpose of PMON, and that is basically roll back the transaction if this guy is doing anything, and then release the locks that are actually acquired by this, and then after that the session will be killed. Many times it does happen that you execute this command, alter system kill session, and with the SID in serial number, and this command doesn't kill the session immediately. It takes maybe 5 minutes, it takes maybe 10 minutes. That is because PMON is working behind the scenes to do the cleanup activity, which is rolling back and releasing the locks. So that is what happens when we type the alter system kill command.
How to find that particular process taking more resources than it is?
That requires a long. Okay, so let me now talk about that. How do you find out which process is taking huge amount of CPU? This requires a knowledge of operating system as well as the Unix. So I will tell you the easier way. You execute the Unix command top. If you execute the Unix command top, then it will show you which process is taking the highest amount of CPU. Those are Unix processes, and then the Unix process will show you what is called as the PID, the process ID. So using the top command, you find out the PID of the process, of the Unix process, which is taking the higher amount of CPU. So this is the process of my dedicated server. Sorry, this is the process ID of my dedicated server. And again, my client is here. So now let us say this PID is 14289. Okay, so that is the Unix process ID of this dedicated server. Now with the help of this PID, we are going to log into the database dictionary and find out what is the SID and the serial number. So we go to a view called as $process. Just like $session, there is a view called as $process. And in that $process, we will be seeing that PID column there. And therefore we would know that this is the Unix process, and the corresponding Oracle process is over there, and that SID can be found out there. So you have to kind of join the $process and $session. $process and $session. So that is what the main thing is. Hey guys, let me just talk for a second.